When talking about particle accelerators, we tend to think of the large inventions that humans created and developed less than 100 years ago, such as the LHC particle accelerator and collider, that people around the world know well, but no one would expect that. In the deep space of the early universe, 13.8 billion years ago, just a moment after the Big Bang event occurred, there is something in nature that acts like an extremely powerful particle accelerator. Theoretical physicists who predicted its existence. Natural particle accelerators from this ancient era are called particle accelerators. It's called bubbletron because it's a rapidly expanding space bubble, until causing the universe to change, including accelerating various particles to their highest energy levels, a type that has never been seen before in the history of the universe. Rapid expansion after the Big Bang, causing the temperature of the newly born universe to drop, and a change in the state of things occurs. This is like the condensation of a gas until it becomes a liquid, or when a liquid turns into a solid. According to the standard model theory of particle physics, status change, the step-by-step pattern of the universe will occur. When the four basic forces in nature that were together as one at the beginning of the universe start separating from each other in order, the gravity will separate them first. The strong nuclear force then breaks apart and acts independently. This is followed by the final separation of the electromagnetic force from the weak nuclear force. The separation of the four fundamental forces in nature is like a change in the state of things in an expanding space bubble. This is similar to the bubbles that form in a pot of boiling water. When a space bubble with turbulent energy is inside, it grew rapidly. Its walls can expand greatly, sweep or blow various particles to move quickly at the same time. This process is like a powerful particle accelerator, which can cause collisions between high-energy particles. It also helps accelerate particles to enormous energy levels. It has never been seen before at any time in the universe, said Dr. Filippo Sala from Italy's University of Bologna. One of the group who presented the new idea explained. Dr. Sala et al. Spread the idea of natural particle accelerators from ancient times. In an article on the online academic archive archive.org, they state that the space bubble acts as a particle accelerator, able to make various particles in the early days of the universe. Collisions of particles at these energy levels are 1 trillion times higher than what the European Nuclear Research Organization's LHC accelerator can achieve. It can cause particles of matter and dark energy to form, including other mysterious space objects that are still a mystery, such as ancient black holes. But the concept of particle accelerators in nature at the time of the beginning of the universe, but it doesn't agree with the original explanation of the standard model. However, Dr. Sala said that his hypothesis opened the way to a more comprehensive explanation of the origin of all things. With special conditions with higher energy levels than scientists had ever believed the universe could reach, his hypothesis could also be validated, with many types of technology available today as well. If natural particle accelerators really existed, Dr. Sala believes we will find traces of gravitational waves that radiated from such a powerful phenomenon by the Einstein telescope. Including gravitational wave observation equipment in space like LISA, there is a high chance of detecting this wave. It is unlikely that the International Radio Astronomy Cooperation Project, the Pulsar Timing Alliance, PTA, tracks the timing of pulsar rotations, which is a great natural watch. Traces of gravitational waves from natural particle accelerators may already be detected. We will have to wait for the analysis of the PTA's large database and the announcement of the confirmation of the results. The universe trembled as well. Background gravitational waves, astronomers have discovered the first direct evidence that the collision and merger of a pair of primordial supermassive black holes. It's something that can actually happen. It also caused the entire universe to shake and ripple throughout. Background gravitational waves, such expansions and contractions of space-time, are similar to the wide ripples that spread out after someone throws a rock into the water. They often arise from extremely powerful events in the universe, such as the collision and merger of the giant black hole at the center of the galaxy, which has a mass billions of times greater than the Sun. It leaves a trail of low-frequency shockwaves that we can still detect everywhere to this day. International Radio Astronomy Cooperation Project. The Pulsar Timing Coalition, which is made up of deep space observing researchers from Europe, EPTA, North America, Nanograv, China, CPTA, India, NPTA, and Australia, PPTA, has published a report on its findings. Found 5 studies in the journal Astronomy and Astrophysics after collecting the above data for 15 years. The results of all 5 studies indicate that after tracking the timing of the pulsar's rotation period, the remains of a dead star that rotates rapidly and precisely hundreds of times per second, along with sending out electromagnetic waves such as radio waves regularly as well. It was found that there was an irregular distortion in the background of space. The unevenness is very small, only about 1 part per billion. Astronomers were aware that such an anomaly existed. This is due to the measurement of the distance between the Earth and hundreds of pulsars. We'll change back and forth a bit. When gravitational waves from a primordial black hole enter the pulsar's transmission line to Earth, this causes the spacetime that is the background of space to always expand and contract, until the signals sent from pulsars reach Earth at different speeds and slower times. Dr. David Champion, a member of the EPETA research team, explains. Pulsars are nature's great clocks. We use a signal that is consistent with its rotation period, measure small changes in the background of space, but it requires continuous observation from many of the world's largest radio telescopes. This amounts to thousands of hours per year. The background gravitational waves of this universe. They are different from other gravitational waves that are starting to be discovered more frequently. Since the first discovery of gravitational waves by the LIGO instrument in 2015, gravitational waves that have never been discovered by humans have been. They are usually single-wave streams, created by the merger of small black holes, stellar or neutron stars. But background gravitational waves are constantly spreading throughout the universe. This indicates that there have been collisions between supermassive black holes in the past. These supermassive black holes are often at the center of larger galaxies that are merging together to form new supergalaxies. Dr. Rebecca Bowler from the University of Manchester in the United Kingdom told the BBC that, in the past, we didn't know that how do supermassive black holes form? We can only assume that there are mergers between smaller and less massive black holes. Until this time, we had the opportunity to directly observe the origins of giant black holes, said AST. Professor Dr. Luke Kelly, a member of the Nanograv research team from the University of California, Berkeley campus, said in a statement from a team of American astronomers that, "We finally found strong evidence. This confirms that a pair of supermassive black holes orbit each other and began to move closer and closer together before colliding and merging into a black hole at the center of the new galaxy. It actually existed in the ancient era." Professor Michael Kramer, member of the EPTA research team from the Max Planck Institute for Radio Astronomy in Germany, finally adding that this discovery is new path for studying the universe. Discovery of background gravitational waves of the universe. It may help us prove at a deeper level that is Einstein's theory of gravitation correct? It may also be said that dark matter and dark energy, which is the main component of the universe, what is it? It could be an open window, so that we can discover a new theory of physics. If you like space stories, you are our friend. Click follow and press the bell so you don't miss any action.